You can see only 10 slides, not super long. You know, you got the title slide and the homework slide. So here we go. So let's first get into what is the geometric definition of a parabola. And I'm going to introduce two new things that you've never seen on parabolas. Focus, directrix. You're probably like, what are these? Okay. Never do those. It's easy. I promise. So parabola is a set of all points in the plane that are equidistant from a fixed point called the focus. And it's spelled just how it sounds, and a fixed line called the directrix. So here's what's going to be new to you, and this is, man, I really wish we had color copy machines. You can see mine, of course, is in color. So you've got your red parabola here, mine's red. So you know what the vertex looks like. The vertex is always the point right in the middle of the parabola. Today, most of them, not all of them, most of them are 0, 0. We'll start with the origin and we'll move off of that in a minute. Then, you are going to have, this is new, a focus. That's the F. I put mine in green. And you have this line called the directrix. So the green, mine's green, green and blue is going to be the new parts that you are going to have to plot on the graph today. Now, other thing on here, so many things, of course, so many things. You have this axis, this mine's blue dashed in the middle. That, you know, axis of symmetry. I'm going to highlight it in black here, and we will mark that today too. So if you fold the red parabola over that black dashed line, of course it matches up. That's your line of symmetry. That you have graphed before. The new parts are the focus and directrix for you today. Okay, so vertex, of course, here, kind of important info because this is going to help me count them out. The vertex is halfway between the focus and directrix. So you're going to be able to tell from the equation how much you need to count. Maybe it's 4. So from the vertex, I would go up 4 for the focus. For the directrix, I would go down 4. So you're using the same amount of units. It's just a matter of which direction you go. Axis of symmetry. That's our black dashed line here. It goes to the vertex. I feel like we're teaching geometry here. And just for the sake of knowledge, it is perpendicular. You can use the geometry symbol if you remember it. To the directrix. So your black, mine's black, dashed axis of symmetry line does make a right angle, just for the thrill of knowledge here, with the directrix. Are we going to do anything with that right angle necessarily today? No. We're going to focus on plotting out or marking out the focus and directrix. So, a little different, a little new, nothing too crazy, I promise. Okay, now you have this big slide on there to look at. So, you can see I just did the vertical ones. That's what we're going to focus on today. Opens up, opens down. You can see I put the equation over there on the board. It's at the top here for you. That's what we're going to be using. And remember, I showed you yesterday, if you're like, oh man, I can't remember the equation. That equation is in your conics menu under applications in your calculator. So we're going to start with our vertex 0, 0. We're going to mark our focus and our directrix. Now you can see all these crazy formulas here. You know I don't like to memorize formulas. That's not how I roll. Now one thing too, it's kind of backwards in your mind, I feel like. Your equation starts with x, so I want to think they're horizontal, but it's not. It's the opposite. The x squared turns them vertical. Monday, y squared will make them horizontal. So it's a little bit backwards in your mind. Now, the other key thing that you're going to use today is this 4p. So the coefficient, the number in front of y. So if that's an 8, that's what our 4p is, 8. That will tell you how many units to count for the focus, how many units to count for the directrix. So I'm really going to be zeroed in on what's that coefficient in front of y. So that's this little note here. P is the distance from the vertex to the focus. And remember, it's the same as the vertex to the directrix. So we're going to be zeroed in on all of that good stuff. Let's just draw one. Okay, you're also today too, flip it over. Some of them will ask for this, some don't, but we are going to do x and y intercepts. I just thought I know you know x and y intercepts, but it might just have been a little while since you've actually done them. So I thought I better put the definitions up here. So x-intercept, the point, or it could be points, depends on how your parabola opens, where it hits the x-axis. I'm pretty sure you knew that, but I thought I'd put it on here. And of course, if you're on the x-axis, y is 0. So if I have to find it algebraically, because you know I like exact answers, I don't want to just guess and approximate a decimal, I would put 0 in for y. Y-intercept, of course, where you hit the y-axis, and notice x is 0. So if I can't just look at it and be like, oh, it's at 0, 3, I might have to put in 0 for x and actually algebraically figure it out. So let me give you a minute to write all that good stuff in, and then let's draw a graph. I'm ready. Worst part, of course, is my drawing skills today. Story of our lives, right? So remember, if you want to check the graph on your calculator, which I'm definitely not opposed to, your calculator is a good tool. Obviously, you can't use your y equal menu today, because these are x squared equals. So you would have to go into that application and the conics if you want to do the graph. Now, you're going to try not to complain about Texas. Well, I know I am. Okay. So we know I am. So you can graph it for sure, and it will show you how it opens. You'll have the vertex. You can figure that out. But that's really all it shows you. I don't think it's super helpful because it's not going to have the focus point marked on your graphing calculator, nor will it have the directrix line. So I don't think it's super great, your calculator, but at least you could get an idea if you're worried about your vertex or you're worried that it's opening the correct way. You can at least get that general idea from it. So here we go. For the following, write the parabola in standard form, list all this stuff, blah, 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 and we'll draw it. Okay. Now, you are almost in standard form. We're so close to standard form. Remember, standard form starts with x squared. All right, big deal. I'm going to get rid of the 4. So I'm just going to divide each side by 4. So on the standard form line, I'm ready to fill it in. I'm going to have x squared, 8 over 4. Got it. Now, I always like to, and sometimes I put a blank for you to answer this too, I always like to jot down how it's going to open, just so I have that in my mind, okay? So x squared are the horizontals, kind of opposite what you would think, positive 2, so it's going to open up, vertical. Opens up. Again, doesn't ask for that, but I just like to know. Okay, our vertex. Just like on your circles, there are no parentheses. There's no x minus something or y plus something. Nothing in parentheses, so we're at 0, 0. Got it. Okay. Now, I'll do the axis of symmetry in a minute. Let's do the new stuff, the focus and directrix. So the key is this coefficient in front of y. That's what your 4p equals. So I want to know just what p is, not 4p. So of course I'm going to divide by 4. What's 2 divided by 4? A half. Not the worst, not the best. Okay. Now, focus here. This is new. To do your focus point, you are going to count the same direction your parabola opens. Ours opens up, and I'm going to count p units. Kind of yuck that it's a fraction, but we're going to ballpark it best we can. So from, just to color code it, from the vertex, I'm going to go up a half unit. Is that actually the half? I don't know, maybe. Let's write the ordered pair. I'm at 0, a half. Then to do the directrix, you go the opposite of the focus direction, the same amount of units. So from my vertex, instead of up a half, down a half. That's the blue dot. Now, your directrix is a line, remember. We go back to one more slide here. Your directrix is a line. So I'm going to draw the line, and that is going to be a horizontal line today, because we're going to open away from it. Love that it's a half. You will get a couple fractions today. Now, all horizontal lines, remember, are y equals. And remember, I went down a half, so I guess it's right on a half, but okay. So yes, I know I need axis of symmetry and all this other stuff, which I'm going to do, but I would really like to actually get like the graph drawn on this thing. So I'm like, okay, I'm going to make a t-chart to get some points, because right now I don't have any other choice, okay? So our vertex at 0, 0, of course. Now notice, though, I'm going to be smart here. On my t-chart, I'm not going to put the numbers in for x like we normally kind of would. It might be a little harder to solve for. Let's put them maybe in for y. So, I mean, it kind of depends, I guess, on how you want to solve it. 1 might not be awful to put in for x. Let's try 1, I guess. 1 squared. I'm going to do the work on the side. 1 squared 1. So a little mental math there. What's y? 1/2. Love the fractions. 1/2. Okay, all right. Let's try -1. -1 squared is also 1. And I'm not at all surprised we get a half because it's symmetric. That's enough. We're not going to get carried away. I'm going to draw my parabola. All right. Now, other things we got to answer. Axis of symmetry goes right through the middle. So that's my black dashed line. It's vertical, so x equals, and hits the center there. And hey, I like this. What are your x and y intercepts? 0, 0, the origin, yeah. So little different styles to draw these. You're going to have to, again, the key is the focus and the directrix are the new parts. Obviously the T-chart, I found the T-chart tedious, a little irritating, so I'm going to show you another way you could have done it. And I don't care really what you do, but I'm going to use this. And plus then I just get to say the word rectum, which I knew this class would really love. So, one of the ways, you can graph parabolas, which is how we're going to start doing it. This will avoid or eliminate the T-chart, is you can figure out the length of the latus rectum. Now, our parabolas today, of course, are vertical. I just drew a horizontal one on here to show you. So latus rectum, what that is, mine's in purple, I wish we had color copy machines, is a chord, here's a good geo word for you, a segment, a chord, through the focus perpendicular to the axis of the parabola. The key is, hi Kevin, the length of it is that 4p. So it's super tiny, focus people, it's super tiny on your notes, but make sure you circle or highlight that the length of it is 4p. So realistically, I'm going to click it back to the last one, I wouldn't have made this stupid T-chart at all. Because I know 4p was 2, so from my focus point, I'm like, oh, I'm going to go right 1, left 1, so I have a total of 2. Done. I wouldn't have had to bother with my T-chart. So that's how I'm going to draw them in the future here. I'm all about less work. Okay, so we're close to standard form. We're close to standard form. Now remember, standard form means to start with x squared. I don't even really think I'm going to write any work. I just know I need to subtract 8y over. Now, I like to write down how it opens. Gentlemen, I like to write down how it opens. You don't have to. Sometimes I put a blank for that for you to fill in, so let's just throw it on here. X squared, of course, are our vertical. -8 is going to make this one open down. And just like on your circles, no numbers in parentheses with x or y. We will eventually have that. So our vertex is still at 0, 0. Got it. Okay. Now, I'm going to do the focus, then the directrix, and I'm not going to make a T-chart to draw it. I'm going to keep it easy. So the next thing I'm going to zero in on is this coefficient in front of y. That's what 4p equals. So I'm like, great, I can just mentally solve that. P is -2. So to get my focus point, you're going to count the same way that your parabola opens. The focus is always inside your parabola. Our parabola opens down, so I'm going to go 2 units down from the vertex. I'm going to write that ordered pair over there. I'm at 0, -2. Got it. Okay, directrix. I go the opposite of the focus. So I went down 2 for the focus. I'm going to go up 2 for directrix. And that's that horizontal line. So I'm going to put that as y equals 2. Now here's how I'm going to graph it. Length of the latus rectum is on there. Some books call it focal diameter. Let's say rectum. So your length of the latus rectum is whatever 4p is. Now I don't need the negative. I care about the 8. The 8 is just telling you how wide it is. So super easy to count. If I want a total of 8, I'm going to go right 4, left 4 from the focus, because it goes through your focus, which was my green dot. So I'm going to go right 4, left 4. and draw it. There is your very lovely parabola. Pretend I hit that down. So you have a total of 8. Sam?
How do you get 8 again?
That's what your 4p is, your coefficient on y.
Oh.
Yeah, yeah. And that's new. That's brand new. You've never done this before.
Wait, you said you go 4 from the focus?
Yep, 4 right, 4 left. Because remember, your length of the lattice rectum goes through the focus. So brand new, you haven't done that. That avoids the whole T-chart shenanigans. I know. Okay, axis of symmetry, right through the middle. So many lines here. So x equals 0 for that. Let's talk intercepts. I'm like, whew, like the intercepts. What's your x and y intercepts? They're both all what? 0, 0. And like I said, eventually we will get off of the origin, I promise. So starting easy. Okay, so any questions I can answer on B? Let's draw another, shall we? Okay, C. Now, this time, notice we're not going to have a vertex of 0, 0. You have those numbers in parentheses, so that's going to change it. Now, standard form, don't be like, oh gosh, do we have to complete the squared, all that shenanigans like yesterday? Not yet. Standard form, you want the squared term, x squared on the left. All I'm going to do, I'm really not going to even write any work. I'm going to keep my x minus 1 squared here, and I'm going to subtract that whole thing over. So I'm going to have negative 8 y plus 2. I need a longer blank. So a little bit of work to get it in standard form, not bad. Now, just like circles, anytime you have a value in the parentheses, you switch the sign. So, negative 1 is with x, so I'm going to put positive 1. 2 is with y, so negative 2. I'm going to go ahead and plot that point for my vertex. It doesn't ask. I always like to write it down. How is this one going to open, up or down? Down. Why? You're right. Negative 8. Got it. I just like to know that, okay? Now, I want to know what p is. That is the key to all of this. So our coefficient in front of the y is that negative 8. And you will see, if you're like, why are there so many 8s and negative 8s? Because obviously we're looking for multiples of 4, and we don't want to get anything too huge, and we're trying to avoid some crazy fractions. So if you see 8 a lot, that's why. Okay, focus point. Count it the same direction your parabola opens. Opens down, so I'm going to go 2 units down for my focus. I'm going to jot down that ordered pair. I'm at 1, negative 4. Directrix. I'm going to go 2 units the opposite direction. So from my vertex, I'm going to go 2 up now. And remember, it's that horizontal line. What's your equation of your directrix? Y equals 0. Good. Got it? What is the length of the lattice rectum? 8. Whatever 4p equals. I don't need the negative. I just want to know the total distance. 8. So from your focus, I want to make a width of 8. So right 4, left 4. Let's draw it. I still got to answer the remaining stuff, of course. Axis of symmetry right through the middle. And your axis of symmetry always hits the vertex there. So I'm at x equals 1. On the right blank there. I really like the x-intercepts. What's your x-intercept? None. Doesn't have to touch both axes. Super happy about that. I like no work. Y-intercept here. I know my drawing skills aren't great. Okay, we all know that. But it looks like it's hitting in a fraction. And I need an exact number for that. Okay, I can't just Hail Mary and guess it. So I'm going to do a little algebra. If you are on the y-axis, x is 0. So I'm going to replace x with 0. And I got to just do a little calculating down here. 0 minus 1, negative 1, squared. Now, you have a choice. You could distribute negative 8 or divide it. I'm going to divide it just because I'm trying to get y alone. I'm trying to get rid of negative 8 and 2. So I'm going to divide by negative 8, fraction time. and I'm going to subtract the 2. Oh boy, fractions, I know you love them. What's negative 1/8 minus 2? That's an easy one. Negative 2 and 1/8. So we put 0 in for x, we got negative 2 and 1/8 for y. And then looking at my graph, it's like, oh, yeah, yeah, that looks about negative 2 and 1/8. We're a little past negative 2. Yeah, I can get on board with that. Seems good to me. So sometimes the intercepts are a little bit of a pain because you're going to have to find them exactly and do a little algebra today. Any questions on that? All right, last thing we're going to do, they're going to give you some information. We're going to find the equation. Okay, we can handle that. Write an equation of parabola. It has a given vertex and information. Okay, so first off, opens up. Well, that's great. Okay, so that tells you p is positive, whatever that's worth. And you've got your vertex. So think about, I'm going to start it here. So my vertex, I'm going to have to switch negative 1 to 1. I have no clue what 4p is right now. I'm working on that. And of course, negative 3, so I'm going to make it plus 3. Okay. So I kind of got to start. We need that p value. I need to know what 4p is for my final answer. So I think I can do this kind of like I did the circles yesterday. I'm just going to take this point, and I'm going to plug that in for x and y, and see if I can figure out p. So let's put 2 in here. And I'm going to put the 4 in for this guy. And I'm like, man, I got a lot of stuff there. Okay, all right. Well, 2 plus 1, 3 squared, 9. Over here I have 4 plus 3. What's 4 plus 3? And then 7 times 4. It's a bad fraction. It's going to be bad, but that's okay. I'm going to divide off 28 gross. Okay. So I think I'm ready to get to my final equation answer and wrap this one up. So x plus 1 is still that. Leave some room here. Leave some room for the 4p. Y plus 3 is still there. Now because our p value is kind of bad, 9/28 kind of is bad, remember when you put it back in here, you want it 4p. So can you multiply this by 4 in your head? So 36 over 28, does that reduce?
8 over 7.
Close. 4 goes into here how many times?
9 over 7. No, 9.
And 4 goes into there 7. So 9 over 7 I'm going to put in my equation. Whew! That's kind of bad, Okay, so let's just recap it. Putting the vertex in is no big deal. Then just like on your circles yesterday, I replaced x and y, and I algebraically figured out what the heck p was. Just be conscientious, though, your final answer is 4 times p. So I had to do 4 times that, which just because it was a fraction made it kind of gross. Okay? All right, let's practice a couple more. So same thing. The fact that it says opens down, it doesn't really help me much. I guess it tells me this would be negative here. That's super exciting. But more of the same. So first I'm going to put the vertex in. So 2, I'm going to make it minus. We're working on the 4p. That's the hard part. Y coordinate of the vertex 4, so let's make it minus. Now, just like on the left side, I'm going to put negative 1 in for x, negative 1 in for y. So negative 1 minus 2, negative 1 minus 4. And let's do a little mental math here. Negative 1 minus 2, negative 3 squared. What's negative 1 minus 4? Times 4. And again, you do get some gross fractions on this, I'm not going to lie. So divide that off, so negative 9/20. So I'm ready to go to my final answer. You might have to do the 4p, do a little work for that, but we'll get to it. So I'm going to re-put in my x minus 2 squared. I'm going to leave my room. I see some of you are on your calculators, no judgment. You could just hit times 4 and have your calculator do it. I'm just going to kind of manually do it. That's not too bad because the 4 and the 20 do what? reduce. So I'm going to have negative 9 over 5. Got it. And again, these are there are some fractions. If you do it all in your calculator, I don't care. I'm not testing your fraction skills today. All right, let's write one more equation, and then I'm going to help you with your homework. Oh, so easy, so easy. Because I like that it says vertex at the origin. So I just have x squared, no number with it, and no number in parentheses with y. Okay, now, little different info though. We don't have a point to plug in. We still need p. Now, I'm a visual person. I'm just going to think about what would this little graph look like. Vertex at the origin, okay. And then my directrix would be down here at y equals negative 1. Okay, all right, I can make it work. So it's gonna, I know it opens up because it always opens away from your directrix. You never cross through the directrix, okay, all right. So now I'm gonna have positive for a lead coefficient. I can tell you what p is. P, remember, is the distance between your vertex and your directrix. Remember, this is at negative 1. So what's the distance between these?
1.
1. Well, put a 1 in here. What's 4 times 1? And I'm just going to double check. Should that be a positive 4 or a negative 4? How is your parabola opening? Up, so I want to keep it positive. And you will see when we get to a quiz or a test and you have to write these equations, I will give you like a piece of scratch graph grid paper if you do like to mark out the picture, because I like to see it like on that guy. To me, it's easier if you actually mark it out, okay? So